recording. Okay. So how do I get rid of this screen? Alrighty. I'll wait till 10. Hello. For this week, I will be presenting on the advanced topic of the metabolic pathway byproducts. So the overview for this presentation are going to include what is found in the glycolysis metabolic pathway, within the Krebs cycles, and then some calculations. So first, in glycolysis, we have a loss of ATP within the first step. We see this due to glucose being turned into glucose 6-phosphate, and we lose that ATP, or as I'm going to keep saying for the rest of the video, investing that ATP. The enzyme we use to invest said ATP is the enzyme hexokinase. Then, at the third step, we have a second investment of ATP going from fructose 6-phosphate into fructose 1,6-biphosphate. Here, the enzyme PFK is being used. Thanks to glyceraldehyde 3-phosphate dehydrogenase, NADH is being created by the product as a byproduct of G3P, being turned into 1,3-biphosphoglycerate. Now this happens 2 times, as I have highlighted here, because the fact that at this split, things go down 2 separate pathways, and you'll see what I mean in a picture that I have in a moment. So with this split, in step 4 going into step 5, we then have 2 pathways, which is how we end up with 2 pyruvates being created. At step 6, we see that 2 ATP are being created because of phosphoglycerate kinase. And then lastly, in our last step of glycolysis, we see another 2 NADH being created. So here is the photo that I was using. Here's the ATP being invested to form ADP. Here we have ATP, once again, so net loss of 2 there. Here's that split going here. We have NADH becoming NAD becoming NADH, ATP reinvestment, and then more ATP reinvestment. And I forgot to mention in the last step how this ATP being formed is being used by the enzyme pyruvate kinase. Within the Krebs cycle, sorry about that, we have in steps 2 and 3 creation of NADH. Now, once again, it's having 2 NADHs because each pyruvate is going to kick off the Krebs cycle. In step 2, the enzyme is isocitrate dehydrogenase, and in step 3, we see alpha ketoglutarate dehydrogenase forming NADH. In step 5, we have the only ATP being formed in the Krebs cycle, and that is due to succinyl synthase, allowing us to have that. Step 6, we have FADH being created by succinate dehydrogenase. And lastly, in step 8, we have another NADH pair being created. So here's a picture of what's happening in the Krebs cycle again. Steps that are creating NADH, those 2, as well as up here, the only ATP is being formed here, and the only FADH is being formed over here. So where does that bring us for our totals? Within glycolysis, we have a loss of 2 ATP, gain of 4 ATP, and the creation of 2 NADH. which this is wrong. It should be net gain of 2 ATP and 2 NADH. Within that step between glycolysis and Krebs, we see 2 NADH being created as acetyl-CoAs being formed. And lastly, within the Krebs cycle, we have a whole bunch of stuff. 6 NADH, 2 ATP, and 2 FADH being created. So moving on to calculations, we see that glycolysis, no, sorry, next slide. We see that 1 NADH is equal to 2.5, 1 FADH, 1.5, and obviously 1 ATP equals 1 ATP. And so how that breaks down, I have this chart here. We see the totals being used of 2 ATP plus 5 due to 2 NADH times 2.5, creating 7 total. Another 2 NADH, so plus 5. GTP was something that I didn't mention, but is back as a byproduct of succinyl synthase, helping ATP being created. 6 NADH to get us a nice 15 ATP being created. And lastly, 3 ATP from 2 FADH is being formed, which brings us to the grand total of 32 ATP. Thank you for listening.